Okay, so let's talk about derivatives of trigonometric functions. Something that's a little bit maybe more interesting than e to the x, because e to the x is a little bit boring, is sine and cosine and like their relationship as far as derivatives are concerned. So the first thing that I want to look at on the graph of sine of x is where we have horizontal tangents. And that's then where the graph of y prime is going to be 0. And then because of things we've talked about before in this class, sine is increasing on this interval. So I know that y prime has to be positive. Sine is then decreasing on this full interval. So I have to be negative and go from 0 to 0. And then sine is now increasing, so my slopes must be positive again. And it just so happens that the derivative of sine is cosine. Let's look at cosine. So using that exact same process. Now, cosine has kind of 3 horizontal tangents if we include 0 and 2 pi. And then cosine is decreasing first, so my slopes would be negative. And then increasing, so my slopes would be positive. Now this doesn't look exactly like sine, but it's like the flip, the reflection of sine. So it's actually negative sine. And what I personally like to use is this little clockwise, round and around and around kind of thing, because the derivative of sine is cosine. The derivative of cosine is negative sine. Well, then the derivative of negative sine would be negative cosine. And the derivative of negative cosine would be negative sine, or back this way. And so derivatives just go around and around in a clockwise fashion on this little tool. I still write it up on the side of papers, and I still use that. So let's say we're talking about a particle. It's moving across a horizontal axis. Okay, and here's our position equation. And I'm just looking at this time interval. When is the particle at rest? So that we know that means that velocity is 0. We first need to find our velocity equation. So let's take the derivative of position. That's going to be 2 cosine t minus, and the derivative of t is 1. If I solve this for cosine of t, I need to know where cosine of t is equal to 1/2. All of that stuff in pre-cal matters? Oh my goodness gracious. All right, let's think about where's cosine positive, here and here. And then I need adjacent over hypotenuse to be 1/2. So I'm going to have the tall triangle. So that means that must happen at t equals pi over 3. And then again down here. So that's 3 pi over 3, 4 pi over 3, and then 5 pi over 3. So all of that stuff from pre-cal is going to come back, okay? You have to be able to solve trigonometric equations. If you need support on that, there are pre-cal videos where I go over that in a little bit more detail, so you want to take a look at those. All right, we can also take derivatives of tangent, cotangent, secant, and cosecant. These are going to be ones that you need to memorize. And when we get into some of our rules later, we'll kind of discover them and why that's the case. But let's go ahead and just look at how to apply them right now. So let's find the equation of the tangent line to the graph of cotangent at pi over 4. Well, let's think about what is the cotangent of pi over 4 first, right? Like if I need to find f of pi over 4. Come on, pen. Okay, well, we can think about this a couple different ways. You can think about it as the cosine of pi over 4 over the sine of pi over 4. Or we can go into our unit circle and know pi over 4 is here, 1 root 2. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 pi over 4. 1 root 2 pi over 4 is 1 root 2 is our special right triangle with a 45-degree angle there. And so cotangent is going to be 1, no matter which way that you look at that. Okay, so on my graph, cotangent when x equals pi over 4 is 1 in the rectangular coordinate system. All right, let's find f prime because that's going to find me the slope. Looks like it's negative cosecant squared x, and I need to figure out what is f prime of pi over 4. So negative, I'm going to write it like this, cosecant, oops, not cosine, cosecant of pi over 4 squared. All right, well, cosecant of pi over 4 is going to be 1 over, let's see, cosecant pi over 4 is 1 over sine of pi over 4. That's 1 over root 2, but I need the reciprocal of that, so I'm going to have root 2. Negative root 2 squared, ooh, cancel, negative 2 is my slope. And so the equation of the line tangent is going to be negative 2 x minus pi over 4 and then plus 1.